Aha! Good way to start a video. Welcome to my first YouTube video, guys. Welcome to Fridge Math. So today we're doing some fucking physics. I don't know if this video, in case you're a viewer that isn't my two friends that need help, I don't know if this video will stay up for very long because, I don't know if this is an academic offense or not. I don't think it is. I think it's a public assignment that you can do with anyone, but the main purpose is just to give two of my good friends some help. I don't even know if I'm fucking right anyways or not, so maybe don't trust this video. I'm not a professor. I ain't shit. I'm just a kid, man. So anyways. 68,000 kilogram boat traveling north at 4.5 meters per second experiences two horizontal forces. The first acts south with a magnitude of 13 kilonewtons, or 13,000 newtons. The second acts 75 degrees north of west with a magnitude of 12 kilonewtons, or 12,000 newtons. The reason I specify newtons over kilonewtons is because maybe it doesn't make a difference, but I know, like, when it comes to acceleration stuff, I know how to do the conversion. I don't know if kilonewtons affects it or not, so I'm not going to fuck with it. I'm just going to change it to newtons, more than likely. So, we have one force that goes directly down, 13 kilonewtons. And then we have a force that goes up to the left, north of west, 75 degrees. And that is at 12 kilonewtons. I'm just going to put it over top of that because it's kind of like the hypotenuse. So I'm going to grab a different color. Oh, not red because that's the fucking color of my access. I'm going to grab green. I like green. So, our components of this vector is going to be here. And then I'm going to tell, some teachers don't like it here. For physics purposes, I like it here. And I'll tell you why I like it here when the time comes. If I feel like it. It's a secret. Those are your components, right? Or this could also be here. But in physics, in my opinion, that's lame. So fuck that. So this is going to be your y component of this vector. So we're going to label this force A. It didn't tell us what kind of force it was. It didn't say if it was applied, mechanical, tension, anything, nothing. It just said there's a force here and a force there. And then this is going to be FB. So this is directly downwards, so this doesn't have component. It's one direction only, no components. Here, this is going to be FA of y, so the y component of force A, and then the x component of force A, or FAX. So you're going to use sine law, or not sine law, SOHCAHTOA. So I'm not a big fan of this version of SOHCAHTOA because cos is actually x over r, or adjacent, which is on the x axis, over r, which is another word for fucking hypotenuse. So, and don't forget your theta here, that's important. So you can rearrange this to get your x. So it's going to be, r times cos theta equals x. So then r dot cos theta, so that's actually going to be 12, which is the length of the hypotenuse. Cos 75 equals x. And we get a number of 3.11 about kilonewtons. 3.11 kilonewtons. You do the same thing for sine. It's the exact same rearrangement. You just take r because it's going to be y over r. And then you get something like 11.6. 11.6. And this is 3.11. So, something that a lot of people don't realize, and I'm just going to add on, when you break it down into components, this is no longer here. This is gone. It is now its components. When you're solving something, you can only pick one or the other. You can pick to solve it with the resultant, which I don't know how. Or you can pick to solve it with its component. Well, that's probably what the R stands for. It's probably for resultant. So now the reason that I like this here is since it's perpendicular to the downwards force, and just pretend that this is straight down. I know it's not on the axis, but now you can actually get the net force of your vertical force, not of the total net force. So this is higher than that, and I don't feel like working with negative numbers, so you're going to go 13, subtract 11.6. I'm just going to erase that, it's not really going to matter. And now your force B, or if you want to call it force C, because it's technically a mixture of two forces, it's different than force B, but I'm not concerned, it can remain force B. This is going to be 1.4 kilonewtons. And now you only have two forces, both an X and Y component, they're both on their axes. You're now going to have a resultant down here. And since you only have two forces, this is the net force. Sorry, excuse me, I just fucking burped in the video. Net force of your two forces. It's just like adding vectors. So then, I know that one of my friends didn't know what I did next, is where you make a table adding, or in my case, you don't really have to do it. You can make a table if you want. You don't have to. But some people like to do, like you go FAX, and then you can go FB, X, Y. I'm not sure if you guys can see that. Oh yeah, you can see it just fine, unless my big ass head is in the fucking way, I'm not sure. And then you have your FNet, which is going to be the same as the hypotenuse, the resultant. So FAX is going to be 3.11, and then this is going to be 0. It's not anywhere above the y. Its y is not changing. And then this would be, so FB, which is down here, it's going to be 0 on the x. It always stays on the 0 part of the x-axis, and it goes down 1.4 kilonewton. So your FNet is going to be 3.1, or 3.11, sorry. 1.4, then, so then your so that's the X and Y component of your FNet. FNet, then, since you have the components, will equal square root of 3.11 squared plus 1.4 squared. And then for the sake of what I said earlier, where I don't know how to fuck with, no idea what to do with kilonewtons over newtons, that's going to give us 3,401.47. I kept it, all the decimals. There has been some rounding through this, for the record. 47 newtons. And then if you want I'm not sure if you can see down there still. Yep. So if you want the angle of this, which is important in my opinion, it's just going to be tan -1 over the components of FNet. So I guess just for the sake of the video, I'll put FNet X, Y over FNet X. And that's going to give, or it gave me in my case, 24.3 degrees. Let me see if you can see that. Yep, you can. So that was the first part where we have our FNet. And I don't know if I have to show you acceleration. Maybe if I move this back and fucking crawl on my ass. So then, Newton's second law, FNet equals MA. So in my question, we have 3,401, and also, for the record, I, on my paper, kept direction, so this is south of west, which was shown right here. So 3,401.47 newtons, 24.3 I'm just going to put an arrow instead of writing south or west. Because this is where our direction for acceleration is going to come from. It's from our force. Because obviously we don't have one yet. Obviously we have the velocity north that was mentioned earlier, but yeah. And then my boat, I fucking wish I had a boat this heavy. Wouldn't be in fucking college if I did. Times, 68,000 kilograms. So then this, you're just gonna put under here. You're gonna divide it. I'm too lazy to write the whole thing. 68,000 kilograms. If you don't know, a newton is equal to a kilogram times a meter over a second squared. So if you divide this by a kilogram, these are gonna cancel. And then you're left with meter per second squared, which is where acceleration gets its units from. And, well, your A is going to equal, about, it's like 0.05, and then there's a few zeros in decimal. It's a lot easier to say 0.05 meters per second squared. And then it's going to be in this direction where it's 24.3 down, like that. That's the first part. I'll cut to the last part.